The Pearl River Estuary is one of the most violently overcrowded stretches of water on the entire planet, a churning maritime highway where more than 4,500 cargo ships, oil tankers, and container vessels crisscross every single day, weaving between two of the busiest ports on Earth. But hidden beneath the surface of this chaotic industrial gauntlet lives something almost impossibly fragile. A small, critically important population of Chinese white dolphins, a rare and intelligent marine mammal so sensitive to underwater noise and pollution that a single poorly planned construction project could permanently drive it toward extinction. When Chinese engineers set out to build the Shenzhen-Zhongshan Link, a colossal 24-kilometer bridge tunnel system designed to slash a grueling 2-hour commute between two of China's most powerful economic engines down to just 30 minutes, they were forced to confront a brutal engineering paradox. They needed to build one of the most ambitious megastructures in modern history directly through the beating heart of the Pearl River Estuary, Chinese White Dolphin National Nature Reserve, a 460 square kilometer protected habitat that this entire project would have to physically cut straight through. This is the story of how a nation obsessed with speed, scale, and record-breaking infrastructure was forced to slow down, rewrite its own construction playbook, and spend billions of dollars accommodating a species that could not speak up for itself. The first, and arguably most consequential decision on this entire mega-project happened long before a single piece of steel touched the water. The route itself. Standard cross-sea infrastructure planning optimizes for the shortest possible distance, the cheapest construction cost, and the most efficient navigational clearance for shipping traffic. But when China's National Development and Reform Commission formally approved the Shenzhen-Zhongshan Link project in December of 2015, planners had already spent years running detailed environmental impact assessments specifically focused on where the dolphins concentrated their movements within the estuary. Rather than cutting the most direct, cost-efficient line across the water, engineers deliberately bent the project's alignment away from the highest density dolphin zones, accepting a longer, more expensive, and more technically demanding route in exchange for keeping the heaviest construction activity away from the animal's core habitat. This single decision, made on paper years before any physical construction began, would ripple through every subsequent phase of the megaproject, forcing engineers to solve problems that a standard infrastructure project would never have to consider. Even with a carefully chosen route, the project still had to physically cross through protected reserve waters. And nowhere was this challenge more extreme than during the construction of the massive artificial islands needed to transition the highway from open-air bridge into underwater tunnel. On the eastern side of the estuary, engineers faced an almost impossible spatial puzzle. The planned artificial island needed to be built close enough to the Shenzhen coastline to connect with an existing elevated highway viaduct, but the foundation piers supporting that viaduct could not be allowed to shift by more than 5 millimeters, an almost microscopic tolerance for a construction zone involving massive earth-moving equipment. The gap between the tunnel structure and the nearest viaduct pier measured barely 2.4 meters, an impossibly tight margin given that the surrounding seabed consisted of soft, unstable soil reaching depths of up to 15 meters. A conventional approach would have used rapid, aggressive land reclamation, dumping and compacting fill material as quickly as possible to minimize construction time. Instead, engineers deliberately slowed the entire process down, adopting a cautious, incremental sand-filling method that stretched island construction out across 3 full years, specifically to avoid destabilizing the nearby piers and to reduce the intensity and duration of underwater disturbance in dolphin-frequented waters. The single greatest ecological threat buried within this entire megaproject, however, was not the artificial islands. It was what lay beneath the seabed itself, layers of decomposed rock that stood directly in the path of the planned underwater tunnel trench. In any conventional marine construction project, removing this kind of rock is straightforward. Engineers use controlled underwater blasting, detonating explosive charges to fracture the rock into manageable pieces before dredging it away, a fast, efficient, and comparatively inexpensive method. But the Shenzhen-Zhongshan Tunnel's route ran directly through the National Nature Reserve, a designated migration corridor where the shockwave from underwater explosions could inflict catastrophic, potentially fatal damage on a dolphin's extremely sensitive hearing and echolocation systems. Project engineers made a decision that stunned much of the international engineering community. They ruled out blasting entirely, choosing instead to rely exclusively on slower, more expensive mechanical dredging and cutting methods to grind through the decomposed rock layer by layer. A choice that dramatically increased both the cost and the timeline of the excavation phase in direct service of protecting a species most passengers driving across the finished highway would never even think about. With the underwater trench finally excavated using this painstaking mechanical approach, the project moved into what would become its single most technically extraordinary phase, the construction of the tunnel itself, an immersed tube structure stretching 5,035 meters beneath the seabed, ultimately becoming the longest and widest tunnel of its kind ever built anywhere on the planet. Immersed tube tunnels are built using a fundamentally different method than bored tunnels. Rather than drilling continuously through rock, engineers manufacture massive individual tube segments in a dry dock facility on land, float them out to the construction site, and then carefully sink each one into a pre-dredged underwater trench, connecting them end to end like an enormous underwater train. The Shenzhen-Zhongshan Tunnel ultimately required 32 of these colossal immersed tube sections, each one an engineering marvel in its own right, plus one final closure joint to complete the connection. But transporting these massive prefabricated tube segments from their factory to their exact underwater installation point required navigating a 50-kilometer sea route through the estuary, involving 7 separate changes of shipping channel, a journey that traditional towing methods would have made painfully slow, environmentally disruptive, and logistically fraught with risk. Facing this transportation bottleneck, the engineering team behind the project made one of the megaproject's most genuinely innovative breakthroughs. Rather than relying on conventional tugboats to slowly haul each massive tube segment across open water, they designed and built an entirely new, purpose-built vessel capable of both transporting and precisely installing the immersed tube sections in a single integrated operation. This specialized ship fundamentally changed the environmental calculus of the entire construction phase. According to Lingdingyang, deputy general engineer on the project, this integrated transport and installation vessel reduced the total dredging required for the operation by more than 10 million cubic meters and cut associated marine emissions by approximately 1 million cubic meters compared to traditional towing and placement methods, a staggering reduction that directly translated into less underwater noise, less sediment disturbance, and a meaningfully smaller ecological footprint across the dolphin's core habitat throughout the tunnel's multi-year construction window. Precision was not merely a technical nicety on this project, it was an ecological necessity, because every single failed or repeated installation attempt meant additional weeks of underwater construction noise disturbing the surrounding habitat. To achieve the kind of accuracy this demanded, engineers integrated China's own Beidou satellite positioning system directly into the immersed tube installation process for the first time anywhere in the world, allowing the massive floating tube sections to be guided into their exact underwater position with an unprecedented level of real-time precision. This technological leap was paired with an equally unprecedented mechanical innovation, an integral prefabricated underwater push-type final joint, a specially engineered connector designed to seal the very last gap between tube sections without requiring the kind of repeated, disruptive underwater welding and sealing operations that older tunnel closure techniques demanded. Together, these two innovations dramatically reduced the number of underwater dives, repositioning attempts, and prolonged construction windows needed to seal the tunnel, directly minimizing the cumulative disturbance inflicted on the surrounding dolphin population across the project's 7-year construction timeline. Beyond the tunnel itself, the project's above-water construction activities carried their own distinct threat to the dolphins: chemical pollution. The construction of bridge piers and other marine foundations across the project required extensive cement mixing directly on the water, a process that traditionally generates significant wastewater runoff laden with alkaline sediment and construction byproducts, all of which would normally flow straight into the surrounding sea. To prevent this contamination from reaching dolphin habitat, engineers developed and patented an entirely new anti-pollution containment system specifically for their cement mixing vessels, a design incorporating 2 separate physical pollution barriers engineered to fully capture wastewater generated during piling and cement operations before it could ever reach open water. This system represented a direct, purpose-built response to a threat that would have gone entirely unaddressed on almost any conventional marine infrastructure project of this scale. Even the fundamental architectural footprint of the project's marine structures was reshaped around dolphin conservation. drawing directly on hard-won lessons from the nearby Hong Kong-Zhuhai-Macau Bridge. A separate mega-project constructed years earlier through the same protected reserve, engineers dramatically reduced the total number of bridge piers required across the water, a redesign that lowered the originally planned pier count by nearly a third. Fewer piers meant less total piling work, less underwater noise generation, and a smaller physical footprint disturbing the seabed and surrounding water column. To further reduce on-site construction time and disturbance, engineers shifted as much fabrication work as possible away from the water entirely, manufacturing large structural components in controlled factory environments on land before transporting the finished sections out to sea for final assembly. A strategy that concentrated the noisiest, most disruptive phases of construction into shorter, more controlled installation windows rather than prolonged periods of continuous on-water fabrication. Throughout the entire 7-year construction period, the project maintained continuous environmental monitoring, specifically focused on dolphin populations and behavior patterns within and around the construction zone. Vessel speeds throughout sensitive reserve waters were strictly capped, generally limited to under 10 knots, reducing both the risk of direct vessel strikes and the underwater noise generated by fast-moving construction and support vessels. Explosive charge limits, even in the rare instances where limited blasting remained necessary elsewhere in the broader Greater Bay Area infrastructure network, were tightly restricted to minimize acoustic shock. Engineers and marine biologists worked side by side throughout construction, treating dolphin protection not as a regulatory checkbox to be satisfied once during initial environmental review, but as an ongoing operational constraint shaping daily construction decisions across the full multi-year build. When the Shenzhen-Zhongshan link officially opened to traffic on June 30th of 2024, it did so as one of the most technically sophisticated cross-sea infrastructure projects ever completed, a 24-kilometer engineering cluster combining bridges, artificial islands, and the world's longest and widest immersed tube tunnel, built at a total cost of approximately $4.8 billion. Within its first week alone, the link processed over 300,000 vehicle crossings, permanently transforming the daily commute between Shenzhen and Zhongshan from a grueling 2-hour journey into a 30-minute drive, reshaping the economic geography of one of the most productive industrial regions on Earth. But threaded through every phase of this record-breaking achievement was a quieter, less publicized parallel mission, a 7-year, multi-billion-dollar commitment to ensuring that the same waters, now carrying hundreds of thousands of vehicles per week, would continue to sustain the fragile population of Chinese white dolphins that called this estuary home, long before any bridge or tunnel existed. Marine researchers working in the Pearl River Estuary have continued monitoring the resident dolphin population throughout and after construction, and while the broader, long-term pressures facing the species across the entire Greater Bay Area remain serious and unresolved, the Shenzhen-Zhongshan link stands as a rare example of a mega infrastructure project engineered from its earliest planning stages not just to minimize harm, but to actively redesign nearly every phase of construction around the survival needs of a single, vulnerable species sharing its waters with some of the busiest shipping lanes on the planet.
The water is kept out during the connection process by using these temporary bulkheads at each end.
Look, 10 o'clock, Pink Dolphin heading east. Copy that, logging the position now.
Near the link, bearing 045.
Got it, looks like they're heading east.
The final compliance review is complete. Everything is in order.
Excellent work. Congratulations, team. Well done.
Over there, look. They're jumping right now. Woo! Wow, incredible shot.
And that is why this tunnel is so important for the dolphins.
I didn't know they did all that work to protect them.